So up next, we have Emily Bishop with UDAF, the Utah Department of Agriculture and Food, who's going to be talking about using plants to stabilize soil and decrease nutrient impacts.
Hello, everyone. Um, Paul mentioned earlier about your local watershed coordinators. I am your local watershed coordinator if you live in the Weber watershed. So Weber, Davis, Morgan, and Summit, I'm your girl. So I just want to start with that. Next slide, please. So I wanted to start off this presentation by talking about why we have nutrient problems. How did we get here? Elizabeth talked about this a little bit, but I'll go into just a little bit more detail because I personally love having context to understand ideas. So I'll be giving that to you all. Humans have been modifying rivers for at least 7,000 years, since the beginning of agriculture. So for 7,000 years, we've been straightening channels, adding dikes and levees, and pulling water from streams. All of these actions lead to increased nutrient inputs one way or another. Now, we obviously haven't been modifying rivers like that for 7,000 years in America, which is why our streams are still better off than many other places in the world, but we still have our issues, right? We wouldn't be here at this presentation if there were no issues. So one of the first things I mentioned when I said we change rivers is straightening channels. That practice is impacting nutrient levels by keeping streams from settling out sediment along their route. If a stream is straightened, like the one in the photo, that water will be moving quickly. And that was probably the point of straightening it in the first place. But when streams move quickly, instead of dropping smaller amounts of sediment where appropriate, they pick up more and more sediment as they go along until they reach a barrier or a slow point to drop it. This causes erosion and is the reason our reservoirs have so much sediment in them. But why am I still talking about sediment? This is a nutrient presentation. Well, sediment is where you're going to find most of our problem nutrients, the phosphorus and the nitrogen. Sediment's really good at binding up those nutrients because sediment was once soil, right? So if sediment is eroding off a fertilized field, it's taking nutrients from the fertilizer with it as it washes downstream. As the soil breaks down in the water, some of those nutrients are released. This is the most dramatic in a reservoir, as there's time for bacteria to fully break down and release the stored nutrients and few plants to take it back up. Next slide. Another reason we have excess nutrients is that we have many ways to add them back into the system. It isn't just agriculture. You guys aren't the only guilty party. We add nutrients into waterways via fertilizer for our fields, our lawns, and our parks, failing septic systems, pet waste, and industrial waste. Watersheds are certainly able to filter some nutrients out, but not at the rate that we put them in. Next slide. The last big thing that led us here, and perhaps the easiest to undo, is the removal of riparian vegetation. We as humans love water. We love to play in water, we love to use water, and we also love to look at water. Who doesn't love to hang out on the beach or at the lake? That's generally fine, but what about the rivers that we love to look at? It's hard to see water with all those pesky trees in the way. So we remove them to improve our view. Another reason for removal that may be more related to farming is that we want to maximize land use, right? You only have so much land and you need to be able to make a living off of it. And sometimes that means you remove trees to give yourself a few extra acres. Next slide. So we know why we have so many excess nutrients, but who cares? Plants need nutrients, right? Well, as I mentioned before, we're putting nutrients in faster than the plants that we have can take them back up. When we have excess nutrients in waterways, we get excess plant growth. And that's a problem because while plants obviously produce oxygen during daytime photosynthesis, they also use up oxygen for cellular respiration, just like all other living beings on Earth. This is a problem at night when plants aren't photosynthesizing and adding the extra oxygen back in. So sometimes there isn't enough oxygen at night for all of the plants and the fish or the other aquatic life. This is especially the case in the summer because warm water holds less dissolved oxygen than cold water. Excess nutrients also lead to rapid growth of algae. We've all seen a reservoir with a harmful algal bloom. When that algae dies, bacteria break down the plants, and while they're doing that, they're further using up oxygen and limiting the amount available for fish. Plus, these harmful algal blooms are toxic to people and animals. Other issues from excess nutrients: nitrogen is toxic to babies, and this can come from just drinking water with too much nitrogen in it. This probably isn't a problem if you have treated tap water, but it could be an issue if you're using a well. Also, acid rain is caused in part by excess nitrogen. Next slide. So, what can we do about it? The good news is that the answer is pretty simple. Plant more vegetation. Plants are amazing at pulling excess nutrients out of the soil and using them for growth. Plus, they keep the soil stable so less sediment enters our waterways. We just need them in strategic locations and to do so where it counts. One of those prime places, a riparian corridor, serves as sort of a last-ditch effort to pull nutrients out of the soil before it hits the water. There's no consensus on how wide a buffer should be. I did look for one. In an ideal world, this would be at least 200 feet on either side, but that isn't always feasible. That's a pretty decent chunk of land to take out of active production. But most sources agree that 25 feet on either side is the bare minimum. I know that can be a little hard because, like I said earlier, you're trying to get the most out of the ground that you have. But these buffers can actually keep you from losing ground in the long run by stabilizing soil and preventing erosion. Your land won't wash away with the next flood if there's a sufficient buffer keeping it in place. And with something like a buffer, if you're interested and able, the more you can add is always better. Next slide. So here is an example of a tree planting I did with a landowner using Utah's Watershed Restoration Initiative. It's hard to tell where the creek even is in this photo because there's no vegetation around it. It's kind of just that rut. It looks like a rut in the ground. We planted a variety of native trees on either side of the creek and then fenced it off to keep cattle from munching the trees down before they have time to grow. This creek is impaired for temperature, so it was a high priority to get some shade along the creek, but it's also grazed by cattle and flows directly into the Lost Creek Reservoir, so reducing nutrient inputs was also a major goal of the project. The fence will be removed after 5 years so the trees have ample time to grow. And if you decide that you want to plant a riparian buffer and you have livestock grazing, you will need to fence it off to give it time to establish. Next slide. So here's an example of a bank stabilization project. The goal of this was to reduce erosion and prevent that sediment input into the stream. So this process in this photo is called a soil lift. So soil is wrapped in a biodegradable fabric and then stacked at a gentle angle to reduce the slope. These practices are often coupled with a planting to keep the soil in place, and you can see that they did one over there to the right, and they fenced theirs off as well. Something like this is a better solution than riprap or concrete because those hard stabilization methods keep streams from slowing down and tend to just push the problem further downstream. If you think you need a solution like this, it would be best to reach out to me or your own watershed coordinator for some guidance. Plus, we could apply for a grant to help you with the cost. Next slide. Another important way to reduce nutrient inputs is to support our existing wetlands or to recreate a wetland where there used to be one. Wetlands are some of the most productive ecosystems in the world. They are nature's filter. So this is the place where water slows down and drops its sediment, and the wetland plants are there to absorb the nutrients and take it out of the waterways. However, as amazing as wetlands are at absorbing nutrients, they can be overloaded by high inputs. They are delicate ecosystems. So having more wetlands would lessen the burden for each and improve overall water quality. Again, this is another project where it would be best to reach out to someone and we can help you with a plan. Next slide. So the last thing I wanted to mention was something called mycofiltration. This method uses mushrooms to purify contaminated water. Typically, this looks like a burlap sack filled with substrate and mycelium. The mycelium grows throughout the sac, and the dense fungal networks it forms filter nutrients out of the water. Some strains of mycelium can actually filter out plastic, and oyster mushrooms are really great at filtering out E. coli. I haven't done any mycoremediation projects because this process is still fairly new. Not many people are doing it, but I would love to see how well it works here. So if you're interested, reach out and we can work on a project together. Um, a few honorable mentions I didn't get to would be mostly because I expect you guys have small farms and not much land, but beaver dam analogs are great for slowing water down and getting some filtering. And then biochar, I know that was mentioned earlier. I haven't done that. Um, but I know it's a useful um, it's a useful practice if that's the route you want to go down. So yeah, I put questions on my next slide, but I know we're going to do those at the end. So thank you for listening.
Yeah, thank you, Emily. Yeah, so just a reminder for everyone to put some questions in the chat and we will address those after the next two presentations.